I'm sorry, but this is a free recorder, so it stops at every 15 minutes. Okay, I'll continue from where it left. It says, so over here, the bone world has the rigid game objects world matrix, and I start assign it to the bone world, and then the bone world is multiplied by itself. It goes through the each of the parents and multiplies the matrix translated from the translation scales and the inverse, and then this world matrix in the bone world in the end of the loop is multiplied with the inverse matrix at the bone index, that is like the multiplying it with the bone pose inverse and then store it into the output matrix over here, and that is used in by the that's been used by the vertex shader over here. So you can see the this part of the vertex shader has been replaced by the whole world bone inverse thing, that is an SSBO over here, and the rest of the part just stays the same. So let's talk about where this SSBOs live. So the animation class holds the four SSBOs. Ignore this two for now, and this is the frame A SSBO, frame B SSBO, and this is the local matrix SSBO, and that is used to store the results of the first GLSL compute files, and then shader buffer object oh boy, and then this SSBO p-bit SSBO is used to store the final result, which will be used by the vertex shader, and the rest of the two SSBOs are used as is saved into the skeleton because it's like an skeleton based, and over here the bone hierarchy and the inverse bone post inverse are the two SSBOs over here. And I like to go through the animation constructors. So over here you just need to create a new object of a shader buffer object, but if you're going to use the SSBO as in the to store the results, that means you're not pushing in any data, then it won't work because it needs to have its structure size and all those stuff. So all you need to push the data into even if it is blank, but you have to push something over there. So over here I have creating the new float and then creating a new float of an size and pushing that into the local ss local matrix and deleting that data later on, and over here they again creating the matrix for that number of bones and then pushing it and then clearing it. But if you don't do it, it just crashes, and that's used for the GPU skinning. And let's run the demo. I have to run it on my NVIDIA graphic card, and I don't know why, but my controls are a bit laggy on this one. So you can see that there are two teddies. The animation speed, I think I should increase the teddy animation speed. Yeah, it looks very weird small. Oh yeah, okay. It's very weird that it won't work on my Intel chip, and yeah. So this all are the animations from the skinning GPUs. Everything is on the skinning, I mean, on the GPUs. I don't know why, but my set positions are not working. I think I messed up on my setting the rigid object things. So right now everything is at the one place, but I'll make it a better demo in this summer, I guess. That being said, let's go towards the compression. Mm, okay. I'll pause the video and find the function and restart. Yep, I found it. So here it is in the display animations. This goes towards through the all the animation stacks, and for each animation stack I'll do the compress and write to file, where you pass in the file's name as in the argument. So Let's go in the method. Over here I created a new structure called frame. It is because like it when I was writing a file, I was writing it in a very weird way where I write all the frame bucket headers first, and then all it was filled up with all the frame bucket nodes, and it would be it's very it's not easy to sort it that way. So I created a object with the called frame, and then that's the vector of the frame. And frame is nothing but the one boolean that says to be capped, that is like it's a boolean for killing it or not, and if it is true it stays alive, or else it just gets killed. And there's one bucket node, and then the vector of the bucket frame bone nodes. Oh boy. And I reserve everything to be 80 just in case. And then I fill the whole thing up with this the whole frame bucket thing, and in the end I have the each frame has the header that is the it's boolean, and then how many bones are there and what's the max pad depth of the bones and all. And let's start with the how I did with the comparison. So basically you start with the anchor point, and anchor point is always started with the 0. That means the 0 becomes the anchor point. You go in there, you increase the candidate by 2, and that is the candidate is the one that says, hey, this is the endpoint of the lerv. Can we get to the can we interpolate between the two, between the anchor and the candidate? And error is it's initialized to be 0, where you just I'd go on till I find everything to be when the error is less than the tolerance, then we just like go on for the thing. And there's edge condition for this. If the candidate so yeah, I'll talk about it. Yeah, and then there's a while loop where this is like the is everything, so it's like this will be false when the tolerance goes above the head. And if the candidate is less than the number of frames, then everything is not okay, and everything, and it just falls, and it increases the anchor by plus plus. And stop screaming at me. So it will increase the anchor, and this will be the edge condition for exiting the loop, where you just like the anchor is less than the frame. So let's say if that it's to edge condition for the last frames, let's give it like that way for now. And we go in there, and if the everything is okay, then I do the lerp slurp and lerp, that is to interpolate between the two frames, and you get the frame that has been interpolated, and that's stored into the result frame. And then I pass that into this function called test array, which will which will check for the magnitude, because in the teddy it was giving me not a number, and when it was because the magnitude was 0, it was trying to divide by 0. And in the humanoid I had to put in this test conditions, where it was like sometimes going the angles was beyond 1 point, it was 1.002, but then it was giving me a weird into the ACOS. And then you just do the ACOS of both of them and find the difference, and add that to difference to the error, and that goes back. You check whether the error is okay or not. If the error is error is less than the tolerance, then this is hard set over here, which can be variable in the future. I'll just add it. Alright, this for future. And then over here I just like go and say, hey, if the error is less than some point, then you just like say, hey, this clip this frame is okay to kill, and you just set it to false, and which will be taken care of later on, and increase the conductor. And if the tolerance is above, then you say, hey, everything is not false, that is to exit this loop over here, and you just break the loop and go out there. and these are the edge conditions for increasing the candidates, or and the it's when everything is acceptable is false, which breaks out of here. What you need to do is like, so the current candidate is not valid one, you need to go one before, so you do this one, and if everything is okay, then you just increase it by one and then continue to check, and you reset everything over here. If everything is okay and or not, you just like change it to anchor to the candidate, and then error is against to be zero because the things goes on. And over here I have, what I do is like check for the how many frames are to be done, and that was just for to check whether how much reduction do I have, and just it's there. I need to and then that reduced number is saved into the clip header, new clip header, and then this whole file is now written. And again I had to create this two for loops before to create the structure back to the frame, because on the engine side I'm still reading the data into the old format, very like, which is a crappy, which I don't like, but I cannot change it right now, so it's going to stay like this for now. And that's how I did the compression. And as a result of compression, so right now all the animations that we saw was the compressed ones, and as you can see, so idle was like 175 and that goes to 32, whereas the punch was 196, but that goes to, wait, this is the other one. Oh boy. Yeah, so that's the uncompressed punch, that is 1358 kbs, and that goes to the punch 196. And uncompressed walk was 52, and then walk becomes the 32. So it's a major compression that I did, and the animations that we saw was the compressed ones. And that's it for my side. Thank you.